In this lesson, we're going to talk about systems of equations. We're going to define what a system of equations is. We're going to look at multiple ways to solve them, and then we're going to start by exploring how to solve them by graphing. First, the definition of systems of equations. Systems of equations are two or more equations with the same variables. Many times they'll have this little bracket on the side, sometimes they don't, but it's two or more equations that have the same variables. And your task is to find the solution, the point xy that makes both equations true. So you're solving them simultaneously because you're going to find the x and the y that work in both equations. In this case, it would be to make it equal 8 and to make it equal 4. So let's talk about how you determine if something is a solution first. Is 1/6 a solution to this system of equations? If it's a solution, then it makes both equations true. So we plug 6 in for y and 1 in for x. I don't need parentheses here because there's no coefficient over y or x. And I look to see, at this point it's a I don't know equal sign. And then at this point we're like, yes, it is a definite equals. So it works in this one, but for it to be a solution, it has to work in both. So we have to test it in the other one as well. Those tricky test makers like to make it work in the first one, but not the second one. So you might try the second one first, just to see. So at this point, again, it's a question. I don't know if it's equal or not. And at this point, I can say, yes, indeed, it does, in fact, equal 6 over here. And so it's a solution to this one, which means it's a solution to the whole thing. So the answer is yes. Now we're going to transition to how do you find those solutions? Well, one way is by inspection. In this particular problem, I can maybe kind of figure out without any particular method or set of steps. I can just kind of figure out like what two numbers would add to get 8 and the same two numbers have to subtract to get 4. So I might try 4 and 4 as my solution, which does add to get 8, but it doesn't subtract to get 4. So it's not that. 7 and 1 add to get 8, but they don't subtract to get 4. So it's not that. How about 6 and 2? 6 plus 2 equals 8, and 6 minus 2 equals 4. So that's the solution. Unfortunately, they're not all that easy to solve by inspection. So here are some other systems that you could try your hand at. You could pause this video and try to figure out what solution would work in both of those. And some of you will be able to figure it out. It's just going to take you a really long time. And we have some more efficient ways than inspection to solve these. The first way, of course, is inspection. Maybe you can just look at it and figure out what it would be. The second method, which we're going to talk more about in this video, is graphing to figure out the solution. The third method is elimination, where you eliminate one of the variables, which we kind of like to do because having x's and y's in a problem is difficult. The fourth is substitution, where you substitute one equation into the other. So again, it's all in terms of one variable. And then the fifth is augmented matrices, which we're actually going to save that for Algebra 2 to talk about. But it is something that you could use your calculator to help you solve them. So technically, I can use any of these methods anytime, but certain problems are better suited for certain methods. For example, this one is already set up in slope-intercept form, so graphing would probably be a good way to go. This one, both of them aren't in slope-intercept form, but this one would be pretty easy to put it in slope-intercept form. You could also use substitution, which I know you guys don't know yet what these methods mean, but you're not going to go through each one of these. You're going to pick, you know what, this one is set up pretty well for elimination, so I'm going to use that. This is kind of like your toolbox of different methods to solve, and some of them are better than others, depending on what they give you to use. Okay, so we're going to talk about solving by graphing and why it works. So remember this problem, x plus y equals 8 and x minus y equals 4. We came up with 6, 2 as the solution. But before we go back to that solution, this is kind of what I was doing, right? I was picking out pairs, all the solutions that give me 8, and then these are all different pairs that give me 4. And if I graph those points on a graph, the pink line here represents all of the things that add to get 8. And the green line represents all of the points that would be solutions to x minus y equals 4. And so the solution to this system is where they intersect, where they cross. If these are all the things, all the solutions to x plus y equals 8, and these are all the solutions to x minus y equals 4, then where they overlap is the solution that's going to work in both. And you can see that's 6, 2. So when you solve something by graphing, you want to graph it and find where they intersect. And that brings us to, sometimes they don't intersect. Sometimes they're parallel. They have the same slope and different y-intercepts, so they would have no solution. If it's parallel and when you graph it, then it has no solution. And this is actually true of any method, whether it's solving by elimination or solving by substitution. Sometimes there's no solution. Sometimes there's infinitely many solutions. It ends up that both equations are the same line. So every point works, not every point, but every point that's on the line is a solution. And then you can also have one solution. So with linear systems, you can have one, none, or many solutions. Let's talk more about how you solve by graphing. So here are the steps. 1, if it's not already in slope-intercept form, you should rewrite it in slope-intercept form. Then 2, you graph the line, and 3, identify the solution or solutions where they cross. All right, let's begin by graphing. So these are nicely set up for solving by graphing because they're already in slope-intercept form. So I can easily identify that m is -1 and that b is 7. So I'm going to start at my y-intercept and go down 1 over 1. And it's really nice to go ahead and continue that slope just as far as you can, because remember, the goal is to see where they intersect. And if you don't have a straight edge to make that perfect, it's difficult sometimes to see where they intersect. For the second equation, the slope is 2/3 and the y-intercept is 2, positive 2. So I start at 2 and I go up 2 over 3. It's always nice when I get to an intersection. One, two, three, 1, 2. There we go. So you can see, of course, I would want to draw the lines. And I'm going to go ahead and use my blue pen instead of changing it. That's the intersection right there. So that point is 3, 4. And you can check. Remember, if it's a solution, it means when I plug it into the first equation, it should work. -3 plus 7 is in fact 4. And then when I plug it into the other one, you get 2 plus 2, which is 4. Some of you have been begging to do 2 plus 2. Look, we just did it. So it works in both. And that's one of the wonderful things about systems is you'll know. You may not be able to figure out the right answer, but at least you know whether you're right or wrong. Let's do another one. It says solve this system of equations. We're trying to find an x and a y that work in both. This one is not set up for graphing well. In fact, substitution might be a nice method to use to plug that in for y. But since we're in the solving by graphing lesson, let's go ahead and set it up so that we can solve it by graphing. Now we have x minus 2y equals 8. There's 2 ways to graph this equation. One is to put it in slope-intercept form. Like so. The other way is to find the intercepts. So I know the x-intercept of that one is 8, and then the y-intercept would be, I can divide both sides by -2. The y-intercept is -4. So you can do it either way, whatever your favorite way to do these kinds of problems is. Right now I'm graphing using the slope and the y-intercept, but you could put the x-intercept as 8 and the y-intercept as -4 and you get the same line. Again, I would continue this line as far as I can so that I can see where these two are going to cross. And they are going to cross somewhere because they have different slopes. If they have same slopes, then there's not going to be any solution. Let's graph the second one. This one's already in slope-intercept form. The y-intercept is 0. And then I'm going to go down 1, right 2, because that's a negative. And they intersect right here. And that point is 4, -2. And I'll leave the checking for you to make sure that it does really, in fact, work. And let's look at an application of systems. A business owner wants to have the front window of his store painted and is considering 2 artists for the job. Stephen has quoted a flat rate of $350 for the job. Fernando's quote is $10 per hour plus $50 to cover the cost of the materials. Depending on how long it takes Fernando to paint the window, these two could end up charging the same amount. How much would it cost at that point? So I'm going to do Stephen with red, and he's just going to charge a flat $350. So his is going to look like this. And then let's make Fernando in blue. Fernando's quote is $10 per hour plus $50 to cover the cost of materials. So he's going to start at 50, and then for every hour, it's going to be 10 more dollars. So 10 hours would be 10 times 10 plus that 50 for the materials. So that would be $150. So that would be right here. So it looks like I'm going up 1 over 1. 30 would be 300 plus 50 would be 350. Yes. So it says, depending on how long Fernando it takes him to paint the window, the two could end up charging the same amount. How much would it cost? Well, it would be $350. That's not a particularly difficult problem, is it? But at what time does that happen? That's the most important thing. And the time is at 30 hours. They are exactly the same. After 30 hours, you would want to go with Stephen. So if the window's going to take longer than 30 hours, the business owner would be smarter to go with Stephen. If it's going to take less than 30 hours, the business owner would be smarter to go with Fernando. This is how you save yourself money as a business owner.